Buongiorno, everybody, and welcome. Thank you for taking the time to come all the way to this side of the building and hear me struggle for 75 minutes attempting to demystify authentication for Office development. My name is Vittorio Bertocci, and as I like to say, my accent gives me away. I live in Redmond, Washington State, and there I take care of SDKs for authentication. So I'm being borrowed to the Office truck. They don't know what we are getting into. But the idea is that given that I operate at the lower level and Office uses the same infrastructure that every other cloud system for Microsoft uses, then I can demystify this for you. There is no hiding that authentication is hard. If I tell you otherwise, you would laugh me off a stage. It's clearly complicated. Otherwise, there wouldn't be in the news pretty much every week someone royally messing things up. But at the same time, here we have a dilemma, because it's also something as mundane as they come, because every day, every application which protects anything worth protecting, so any application worth using, uses authentication. So it's something which happens every day. So is it complicated? Is it mundane? How is it working? You know what else is complicated? Woodworking. Did any of you ever try to do something out of wood?
Too hard.
All right. And you have all of your fingers still? That's amazing. So I tried when I was younger, and really complicated. You need to know about type of woods. You need to know about glues. You need to know how to operate sharp objects. It's super complicated. Like if I'd ever have to rely on my ability to do that for sustenance, I'd be completely, I can't say because they are recording me. And yet, this is my living room. I'm very proud of it. Also, I didn't want to pay royalties from anyone, so I took a picture myself. This is my living room, and you can see all of that furniture, and I assembled it myself. 10 fingers. Thank you, thank you. It wasn't easy, but I did it. And how did I do it? I did it with one magic item. This, the Allen branch. With this guy. This little guy, and with instructions. I followed very closely instructions which were designed by very smart engineers in some Scandinavian country, which know absolutely everything that there is to know about the furniture. And they prepared things so that it protected me from the usual mistakes. They put me on rails, they gave me instructions, and I didn't have to learn anything about the laws of physics of woodworking. So I just followed instructions. And they even accounted for contingencies, like every bookshelf is actually anchored to the wall so that if, like in Seattle, we live on top of a volcano, if it shakes a bit, this thing doesn't fall on pets or kids. I don't have kids, but still. In the eventuality, they will not be killed by my boots. So authentication is not very different. It can be easy, or at least predictable. The vast majority of scenarios are well-known scenarios. You're working on an iOS app. You're working on an ASP.NET application. You're working on an Office add-in. Those are well-known canonical scenarios. For those, we give you SDKs, our little Allen branches. We give you very detailed instructions for going through these. So during this session, I'm going to do exactly that. Actually, sorry. Let me take it back. How do you reconcile these with people complaining about authentication being hard? Two main reasons. One is that sometimes your customers ask you for very challenging deployments, and then like you are not in the canonical situation. The other case is when you are trying to take two different pieces of furniture and merge them into one. If you want a table that is also a bookshelf, I'm sorry, you do need to learn how to do glues and similar. I cannot give you easy instructions for that. You need to become an expert. But for these, for today, I'm just going to give you the basic patterns for the main scenarios that you might encounter, and then we'll just mention a bit the laws of physics so that you can troubleshoot. And if you want to go deeper, tomorrow I have another session, but I'm pretty sure that you won't. So that's exactly what I'm going to do. First, I'm going to give you instructions for how the generic pattern for authentication works. Like if you squint hard enough, every single scenario will look like this guy. It's a very high-level pattern. Now, you'll see here that I have a fake Scandinavian names. Don't Google for them. Like, they don't correspond to anything. That's just part of a joke that I'm doing across this thing. So don't give them too much credence. Laugh if you want, but don't Google them. Then after this, we'll get more into the core of Office development, which in large part is actually almost exactly the same as every other authentication that uses Azure Active Directory. And, but there are some specific things that I'll call out, like, for example, Office add-ins and, of course, calling the graph. Then, well, of course, I'll talk about an add-in. I'll talk about creating single-page applications which invoke the graph. And then, if I manage, just to set expectations, this stuff is really long. So I'll try to get also to web applications which use their code behind to call the graph APIs. The good news is that all the other patterns before this one will introduce all the actors and all the SDKs that you need to use. So even if we don't get to that, you'll still go home with your newfound skills for building this stuff. Does that work for everyone? Yes, no, more coffee. Very good. So when you feel the evil, remember that you said, yeah, it works. Very good. So let's start. So here we have our high-level pattern. And if you ever built something, like a bookshelf or similar, you'll recognize the pattern. You have all the components on one side with how many there's of those, and then there will be just steps. Of course, putting numbers here would not be very fun, so I'm just going to do it on the fly as we talk. So here there is the classic pattern. Of course, you have your application, and here can be any application, mobile app, like any kind of application you want. Here I'm just using the mobile icon because of how to say, convenience. Then, of course, you have users that you want your application to cater to. And these users will typically live in the cloud. Well, not really. They can live anywhere, but here my sponsor is my Microsoft Cloud Services, so I have to say that they come from the cloud. And in our specific case, they come typically from organizations, so Azure Active Directory users, or from MSA, the artist formerly known as Live ID, which they don't want me to tell, but I say it anyway. And they live in there. And typically, there will be one resource, like one web API or more, that you want to grant access your application to. And spoiler alert, it's going to be the Microsoft Graph every single time for the next 70 minutes. Otherwise, they don't pay my salary, so it has to be the Microsoft Graph. OK, now, how do you go about developing with our platform for making this scenario thick? So the first step is typically go to some development portal. We have a large variety. Like if you want to, no, I'm half joking. There is one specific portal that we'll be using across all this session, which is the portal that you use for every Office development. Then we still have other portals which we created in the past for some other scenarios. And if you have questions about that, feel free to come over after the session. But here, I'll be always talking about the newest portal we have. So you go into this portal, and what you do is you register your application. You let your identity provider know about the existence of your app. Now, the identity provider will already know about the resource that you want to talk to. So it will have a little representation of it in its own database. And all you need to do is to go and to describe your app. And depending on the flavor of your app, you'll give different descriptions. Like if it's a mobile app, you can say, this is my bundle ID on iOS. How many of you guys develop for iOS? 1, 2, 3, 4, 5. How many for Android? The same, almost the same people, some overlap. Great. What about for Windows Phone? That's just for seeing if you are still awake. Okay. So once you've done this, then the next step is you take our Allen branch, our SDKs, and we'll see all the variety of those. And you just put it inside your application. And then you'll configure it, typically with an identifier, which says, yeah, this is how Azure Active Directory knows about my app. And then you dance. When you need to call your application, substantially, you just call your API, you call the SDK, and from the SDK, you will obtain some kind of experience for authentication. Depending on your kind of app, it will be a different experience. It can be a pop-up in front of your console on the desktop. It could be a system browser on iOS. It could be the browser itself if it's the web app. Whatever the mechanism, the SDK will take care of showing UI and format requests so that you can ask for the token you need. And then a token back you will. Here where you have your access token. And then once you have it, typically all you need to do is send it to your resource. And that's the end of it. This is the universal pattern that you can use for pretty much every system. So whenever you find yourself confused, just fall back to this. Everything is always like this. You just change the OS, you change the dev stack. You might compose more than one of those, one after the other, but it's all the same. Yes. No. More coffee. I'd say more coffee. OK. Now that we have seen the high-level pattern, let's spend a moment to think about the Office development platform. There are substantially two macro options you have when you want to integrate with Office. One is you have your own application, mobile app, desktop app, single-page application, web API, and you want to enrich their capabilities and make the application smarter, like Yina, who just entered, like to say, and by calling the Microsoft Graph. How many of you guys were in Yina's session? Many. Yina, you are supposed to say yes. You were there presenting. Great. How many of you ever used the Microsoft Graph? Excellent, very good. I have a few introductory slides, but largely I'll expect that you guys already used it. So that amounts to calling a web API. Web API, which is very well designed, very well supported in all of our stack, but yeah, that's what happens. The other option you have is to actually have your application living directly within the experience of Office. So for example, you can think of like classic Office clients, Excel, PowerPoint, Word, Outlook, and you can actually carve your own niche inside of their UI and enrich the user experience with your capabilities. And once again, this will entail also calling the graph. Now, during this session, I'm going to talk about mobile applications, single-page applications, and web applications calling the graph. And I'm going to talk about the SSO add-ins for Office clients. And those are like the main areas where I'm going to touch. And then everything else can be interpolated from those. OK, so now we have seen the abstract model. Now let's be more concrete about what we want to do. So here you'll see me just reinstantiating exactly the same pattern. The resource we want to talk to is the Microsoft Graph. This time, your application is a mobile application, which can be pretty much anything you want. iOS, Android, Windows, which means desktop, means UWP, and similar. I could leave this thing in here to remind you that it's possible, but to the crowd of instructions. So you have seen it, you'll remember it. So I don't need to leave it in there. OK, we still have users living in an Azure Active Directory instance or in a MSA. Always living there. Well, let's put the user here, I prefer. OK, the portal that we want to use is appsdevmicrosoft.com. That is the portal that we use for doing for registering this kind of applications. And the SDK that we want to use is the Microsoft Authentication Library, or MSAL for short. And I'll add details about what that is in a short. So the flow is pretty much as we were saying earlier. You ask to your SDK to get a token for your user, and you'll get whatever experience the authority the users belong to. So if the administrator of that user decided that they must use MFA, they'll see MFA. The good thing is that in your code, you will not have to make any provisions for that. You just get these out of the fact that you're using an SDK, and this SDK knows how to deal with those things. And as a result, this time you will get an access token and a refresh token. And we'll talk about the refresh token in a second, but for this specific case, this is pretty much the same scenario that we mentioned earlier, in which now that I needed to make my call, I just make my call to the graph, and my call simply brings along my access token, which represents the fact that the user successfully authenticated and successfully consented to make a call, and that's it. Very easy, very straightforward. Now, before I actually make it happen in Visual Studio, let's talk for a second about the SDK that makes it happen, the Allen wrench. By the way, if at the end of it someone wants it, I'm happy to give it to you. That is the original one I actually used for setting up all of these. So it's magic. Our SDK is a franchise of libraries. Those are multiple libraries which live in different OSs. We have native ones for iOS and Android, for the 5 people in the room that do that. And we have .NET ones, which work on .NET Core, on desktop, on UWP, and also, of course, work on Xamarin, so you can also target all of these other things. Those are all different libraries with the same name and with the same primitives. So once you learn how to use one, you can transfer that knowledge to another platform, of course, modulating it depending on the practices and the syntax that you expect on the platform. Like typically, for example, on iOS, every method will end with name of the first parameter. I don't judge. That's what they like to do. But the primitive is exactly the same primitive across the board. They are fully open source. How many of you ever contributed to an open source project? All right, great, excellent. So if you wanted to add features, do pull requests and similar, they are always welcome. In fact, we have some big features in MSAL which have been entirely contributed from the community. So really works, and also full transparency. You can see exactly what we do. And this works across MSA, this works across AAD, and depending on the platform where you are, despite this consistency across the board, we take advantage of the capabilities of the operating system. So for example, in the latest Android and iOS, whenever you need to present the user with an authentication prompt, you can actually invoke a system browser, which shares a lot of context with other apps, so gives a better experience. I'll give you a demo of that. So when our libraries run on those OSs, we take advantage of these. Like, we look at what's available, and we take advantage of that. And the basic coding pattern is absolutely trivial. How many of you ever used the library ADAL? All right, thank you. ADAL was the former generation of our client SDKs, and it's been in market for something like 3-4 years, and it was very well received, but of course was a first generation. So we learned a lot from you guys using it and giving us feedback. So in MSAL, we honed the object model so that it is much nimbler, and it requires you to write way less code. At this point, I'd say that the next step is reading your mind. We can't ask you, we can't make it much smaller. The main pattern, the minimal program in this is you declare your application. You you create one object which represents the entry of your application in Azure Active Directory. And you initialize it, typically with all the information you want. You can customize everything. But the minimal is the identifier that you got when you registered the app, your client ID. And then you just say what is the operation you want to do. In this specific case, I want to be able to read mails of a current user. And then I just ask for a token which is capable of doing this call. That's it. Is it demystified enough yet? It's 2 lines of code, and it's true that there is a GUID, and GUIDs are ugly, and for which I apologize. But they are unique, non-reassignable, and immutable. So There is that. OK, so let's do some Visual Studio hopping. So let's come back to our pattern. So now we are going to go here to register our application. We are already there. So today I want to be Mario, I think. Yeah, I am Mario. You can sign in this portal with an organizational user or also with your personal account, and this will work beautifully. You don't need any Azure subscription or anything. If you right now navigate in there, you'll be able to start using and registering apps right away. Now, eventually, as soon as the electrons go all the way to Redmond and slowly come down all the way to Florida, come on, there we go. As you can see here, I've been using this portal, and all I want to do is to just create an entry for my application. It's a mobile application. So let me click on Add an App. Let's call it Ignite Mobile 2017. I could check this thing and go through a step-by-step guide for building this, but of course, I like to go without training wheels. So you'll see that it's actually super simple anyway. So once I click Create, I just reserve one entry for my application. But this application is still shapeless. Like Azure AD doesn't know what I want to do with this. And so the next step I need to do is to come in here and choose which kind of job I want my application to perform. And in this case, I want it to be a native application. Now, there is always a problem to identifying this kind of apps. Sometimes you say mobile application. Sometimes you say public client. Some other times you say installed applications. Some other times you say rich client. They are all the same. Anything which is not running in a browser, it's typically a native application. Of course, I'm excluding the server side of the house. So let's say that I want to be native. Very good. Save right away. If you forget, it's a problem. Very good. So given that I'm going to do a desktop application, this is all I need to do. All I needed was to have this application recognized and have this string, which I will use in the code which I described earlier. Very good. So now let's focus on this part. Let me build the application in itself. And I know it's not fashionable, but I'm going to do a WPF app, just for surprising you. You were expecting UWP, right? No, let's do a WPF app. And let's call it OK. And here, like, I'm not starting from anything so that you don't think that there is some trick which happens behind the scenes. I'm just like starting from a blank slate. I don't even have a UI, but luckily I'm Italian, so innately I'm good at design. Hey, why are you laughing? I'm entirely serious. Name, button, click me, sure. Content, click me, and I want the event click. Want a new one. All right. See, I'm not leaving the user any choice. If I click on the window, I'm going to click the button. OK. So next, we want to add our MSAL library. So I'm just going to NuGet, and I am searching for MSAL, and promptly, there is none. Here it is. All right. So you'll see that MSAL is in the preview feed. We are in an odd quantum superposition state right now, in which we support, like we are in preview, but we support the use of the library in production. Like we've been taking long to come out with this thing, so we decided that you can use it in production and you can call support and we'll help you. But it's in preview. Let's say that eventually, once we hit GA, the surface, the API surface might slightly change. So for you to pick up the GA, you might have to change some API. But that's the only gotcha. OK, did I install it? It looks like I did. Very good. Now, let's add the code which I described earlier. Is the code big enough for you in the back? No. It's 150. How much do you want? 200. Is it enough for you now? Excellent. Very good. Are you in a bad mood, Yena? Why are you looking at me like so upset? Am I saying something wrong about Office? I warned them that I don't work for Office, so they shouldn't take what I say at face value. Very good. Excellent. So first thing, I will declare my application. My application is an object which, of course, represents my entire app, so I'll do it as high level as possible. Normally, I'll put it in app.cs, but here I'm just putting it in the main activity because, again, I'm lazy. Another side effect of being Italian. Now, of course, I'm joking before people blast me on Twitter. I'm joking. OK. Here, I declared my public client application. I'll give it a fascinating name and null it. And then I'll just initialize it when I initialize the window. New public client application. Good. And here, what I need is the identifier, which we had in here, which is conveniently already highlighted. Copy. OK. So now I have one object which represents the entry of my app in the directory. So now I can use this entry for doing things like getting the tokens that I need. So first, let me declare the kind of operation that I want to perform, which was mail.read. So I need an array. Mail.read. It's case insensitive, but I'm superstitious. You know why already. So let me capitalize it. OK, so let me make this guy async. Everything is better when it's async, I'm told. And now I will declare an authentication result, which is from where I get my tokens back. And this authentication result I will obtain by asking my application to get a token for me. And the only thing I need to specify is the scopes. Now, this is the simplest possible scenario. Then I might already know the user, and so I might pass the user I want to use for authenticating. Or I might want to influence the way in which the UI comes up. So there are lots and lots of options. Here I'm showing you, again, remember, you just got the package from the furniture seller. They are not giving you any advanced stuff. They are just showing you the basics. OK. And now I could cheat a bit and add a bit of pre-packaged code. Now, this pre-packaged code is added in this fashion instead of typing because there is a lot of it, and because there is no really identity content, authentication content. This thing is just the code you would normally use for invoking a web API using HTTP client. I'm not using SDKs for calling the graph, just for showing you like the raw calls. But of course, you heard in all the other sessions that there are very convenient SDKs with IntelliSense and similar. But as a blue collar, I prefer to do it. It's actually blue today, to actually call things directly in REST. The only thing which is of relevance for authentication perspective is the following. Here you can see that I craft the HTTP message simply by specifying the entity that I want to read. In this case, the messages of a currently signed in user. And then this is the important part. In order for my request to be accepted, I needed to attach the token to the request, which is exactly what you observed here. It's sending the token. And the way in which you could do it in code is you just assign the access token that you got back in your code as a header. So let me just place actually a breakpoint in here, and let me play this guy. Usually it doesn't work at first. If it does, we have to be suspicious. Something is wrong. All right, here is my marvelous large Italian button. I click on it, and as you can see, ta-da, dialog comes out. And just to show you what I have in here, here the dialog picks up the users that I already used recently, and so it gives me a chance to select one of them. And as I said, I want to be Mario, so I click Mario. And the password is... OK, now this one is important, and I'll ask you to remember this, because later on I will talk about what's happening right now. Right now you don't have a context, but focus for a second on what's happening. I just successfully authenticated. Now Azure AD is telling me this application is trying to perform all those operations on your behalf, which amounts to knowing information about you, being able to use this capability even when you are not signed in, and read your mail. And that's what we call the consent screen. And if I accept, then what happens is that I actually get a token back. Otherwise, Azure AD would have evolved that saying, OK, you don't want it, I will not give you a token. Now, if we look at this authentication result, every time is a little dance to be faster than Zoom it. And Zoom it always wins. That's unnerving. Now I think I found a trick. Now, you can see here the content of the authentication result. There is a lot of stuff, which largely you're not going to need. The main thing that you care about is the access token. The access token is the thing that you are using for making the call. And now I'm going to do something which normally we tell you not to do, which is to actually pick inside the token. Now, this token is a token which is meant for the Graph API. The Graph API is the recipient, intended recipient of this. So if you write code which tries to consume this code will break. Eventually, we'll start, for example, encrypting these tokens, and so you will not be able to look into that. So don't try. The only thing you can do with this token is to send it to the Graph, and then the Graph will look at it, validate it, and similar. But given that we are not yet encrypting it, I think it's instructive to show you what's inside. So let's take a look at that. Here there is a very handy utility site, jwt.ms, as you can see here, where you can paste the bits of your token, and you can be guaranteed that this tool will never send tokens to our backend. This is purely for the decoding them so you can look at them here, but it all happens in the browser. Tokens are, I cannot stress this enough, a way of accessing things. It's a credential. So be super careful about where you paste them. And also, they contain personal identifiable information. So be doubly careful, especially if you live in Europe. How many of you guys from Europe? All right. How many from Asia? All right. It's just you. And what about South America? Yeah, you are really from Washington. Now it's from Washington. It's, someone asked me from Italy, I say, no, I'm from Redmond. Anyway, here there is the content of the token. And you don't need to know the things I'm telling you right now. This is more for helping you if you will need it to troubleshoot. This is a bit of behind the scenes. You don't need these for successfully completing the instructions. The audience claim is a component which says this token is meant to be spent with this resource. Any other resource will refuse this token because receiving it would be equivalent to receive a bank check which is not for you. You will not accept it as a payment, right? Then there is the issuer part, which says this token is coming from this organization. Every organization will have a different value. So if, for example, you're writing an app only for your employees, you will refuse anyone that is not your own tenant. And then what else? Yeah, and here there's the scope. The scope is what makes the access token the access token. This represents the delegated permission which the user granted to the application. And we'll see in a second what that means in practice. OK, let me zoom this back in. Now, probably the app timed out, but let's let's try to use the token anyway. Boom. What you see in here is a beautifully formatted set of messages. Well, not formatted at all, but that's the verbatim that I got back from the graph, which proves that I was successfully granted access to the mails of a user. OK, now let's go back for a second about this scenario. Now, typically, all the demos now end, because I've shown you the 2 lines of code, you are happy, and that's it. But in fact, if you wait a bit after the demo, things can get interesting. The access token that I used is an independent piece of credential that can be used for accessing that stuff at any time. So it never calls home. When the graph receives this token, it doesn't need to go and call any API for validating it. It's entirely self-contained. But this poses a challenge. Say that the user gets this token, sends this token, and then somehow gets caught stealing and gets terminated on the spot. Now they have this token, which can still allow them to act as their former self before they were fired, which is a problem. So on one side, not having to call home makes you scale like crazy, it's really super handy. But at the same time, then you have this kind of problem, the problem of revocation. So the way in which auth, how many of you are familiar with auth? Some. It's a protocol used for authorization purposes between entities that more or less trust each other. The way in which this is solved is to put an expiration date on the access token. Our access token by default lasts 1 hour, but now you can actually change this value as much as you want. After 1 hour elapsed, it will no longer be valid, and so the graph will refuse it. Of course, you don't want to prompt your user once every hour, because your business will be short-lived. So what happens is that we have this other artifact, the refresh token, which can be used for going back to Azure AD and saying, hey, 1 hour ago, this user successfully got a token from you. Here there is a proof. Can you please get a fresh one? And that's exactly what happens. If the user is still employed, then you'll get back a new graph token. And then at that point, you'll be able to just keep calling. And the good news is that we do this for you. If you always ask the token to the library, then you can always get back an access token. Like you can always get back a fresh access token, and we do this refresh thing automatically for you. You don't even need to know. I'm just telling you so that you don't think it's magic. So let me change the code so that we can take advantage of this capability. But first, given that there is a demo which takes a long time, let me warm up another demo. So the method that I called earlier, the acquire token async, has one characteristic, which is it guarantees that we will show the UI. So it doesn't matter whether we already have tokens in the cache. If you are calling the token, if you're calling that method, you are guaranteed that we will prompt the user with the UI. So this is all for situations in which you want to prompt the user again. But of course, in our case, we don't want that. We just said that we wanted to get the first token and then keep, and then just get it silently instead of prompting the user again. So let me change this thing slightly. Let me declare the authentication result here. Let me do a try block. And inside this try block, I'm going to make another call. Instead of calling acquire token async, I will call acquire token silent async. This is the opposite. This guarantees that you never show UI. If I can get you a token without showing UI, good. If I can't, I'll raise an error, and you'll handle that error in whatever way you want. And here I can, once again, pass the scopes. And then here I also have to pass the user. And I want to comment because there is a disagreement between me and my developers here. So I'll just tell you how it works without making any commentary. And here, substantially, I have to specify the user that I want to use when I'm doing this operation. And the way in which I can do it easily is just to take the application, go in my collection of users. Like every time I get a token for a user, this collection gets a new entry saying, hey, I have a new user here, and those are the tokens. And given that it's a collection, I can just call this first or default, and I will get the first user that I have in my belly. If I have no user, this will return null, and so simply will acquire token silent will fail. Okay. And now, in the case in which this fails in a very specific way, and specifically with the MSAL UI required exception, it's something which the library tells you, I tried to get a token without showing UI, I couldn't. So do what you will. And the reaction is to do exactly what we were doing earlier, which is to call the interactive version of acquire token. So let me place a breakpoint here, and let me run this thing again. I'm sorry, say again? Ah, thank you. You saved me from shame. Actually, already having to receive that is shame, but smaller. Great, thank you. Okay, let's do this again. Now we are here. Let's try to get this thing silently, and of course, we didn't sign in, so we are now in our catch block. So here, you are familiar with what happens. I am Mario, and this is my password. Okay, what happened here? Somehow this thing didn't work. Sorry, I know that debugging on stage is never a good idea, but Mario, password. Well, I got my token. I have an access token. So why are you complaining? This looks like a socket thing. Like AR access token has value. And it worked. Well, it's like, I don't know what to say, guys. Like I didn't touch anything. It just it decided to short my telomeres a bit so that now my life expectancy is shorter. But anyway, now let me click the button again. And this time, this thing pops out without any dialog. You can see that I'm using the cached version of this. OK, so this one was the absolutely minimal version. But let me show you the other demo which I warmed up, which is a Xamarin version of this demo. How many of you guys ever used Xamarin? It's magic, right? Like you write code once, and then it works everywhere. And for our SDK, that's exactly what happens. Like you can see the shape of the solution. All the code is in the portable library. And then everything else is just doing little adjustments for the platform. Like you have slightly different redirect URIs, which account to the type of model that you use for the platform. But apart from that, all the code is exactly the same. So super, super handy. Now let me see if we manage to convince our emulator to actually show the application. Now I'm showing you Android because bringing a Mac all the way to Florida would have been bad for my back. So I'm using, but this works exactly on iOS as well. So here we have a very simple application, which instead of showing the emails, it shows the user. As you can see in here, this application was already signed in. Like in iOS, Android, and UWP, we have isolated storage for apps. So we have a canonical place to save the tokens. So we do that persistently for you. So that once you run this thing once, we save your session, and you don't need to worry about that. Your user, every time they open the app, will have it. So I left it in this state so that you could see it. Now, let me hit sign out. So I start from scratch. And now I'm going to show you is another characteristic of being on the mobile platforms. Once I hit sign in, what happens is that I'm invoking the system browser. This is the system browser Chrome on Android and Safari on iOS. And this thing already has all the cookies that I have for websites. So Mario here is already signed in. So I don't actually need to click, enter any passwords. I can just click on this guy, and then I come back, and ta-da, I'm back in. So all the capabilities that are available to the platform, our library make available to you without changing any of the code. So whenever something can happen in that library, in that platform, we'll make this happen for you. All right, good. So that makes our mobile part. And now comes the more colorful part. But before this, I spoke about this. You have seen the code that I wrote. I never save my access token in a local variable. Whenever I need the token, I ask to my library so that the library has the opportunity of using the cache, of using a refresh token. If you do this, you'll be fine. Now, Ina is in the room, so I feel a bit self-conscious in talking about the graph. But just high level, you guys are all familiar with the Microsoft Graph. It's like the front door for all of our Microsoft Cloud capabilities, or it's rapidly becoming the front door for all of them. And here I'm focusing mostly on the user, which is like the center of this large sprawl. And you can use the graph for percolating through organization and user information. You can get access to the content that the user produces or collaborate to. And you can have transient things like conversations, events, calendars, and similar. And finally, you can extract intelligence out of this. Like, for example, depending on the activity of the user, you might actually detect what are the other users that are most relevant to this person in the context of work, business, and similar. Again, I know that if I'd go in the details, I'd definitely say something wrong, so I'm staying safe at this level. And just to give you a feeling of how this thing works on the wire, here is exactly how this works when you want to retrieve those attributes. Those are super simple things that you can do from pretty much any device. There's like the lowest REST layer that you can think of. So you can simply do get operations for retrieving the user attributes themselves, and you can also get navigational properties such as navigating the graph through the relationships that the user has. And you can, of course, have access to the content that the user deals with, as I described earlier. You can get the insights that I hinted at, as in the warp signature that the user leaves as he or she operates across the organization. So super cool. Was it enough? No. Sorry. Very good. So every entity that you work with a graph will have associated permissions to it. And your application will need to acquire the necessary permissions to access that. And while we were preparing all the various slides and similar, I found myself having to explain to some of my colleagues how this works, like how the delegation works and similar. And the funny thing is that you can use a formal language and you'll be foolproof. You know that you'll be describing this in a mathematically solid way. But not everyone wraps their head around the formal language. So I thought to tell you a silly story to clarify the concept. Now, imagine that here there's yourself. And imagine that you have some assets. Well, not this fat. No, why? I'm dieting, so I am sensitive to this. Okay, good, well proportioned. Say that you have some assets of yours, like you might have some cookies, which you are saving for later, you have your favorite newspaper, and similar. And say that you also have a dog. And say that you go in your garage to work on your personal project, and you bring your dog. And say that there is some relative, your mom, your spouse, at home. Let me differentiate. Voila. Okay. Now say that you are waiting for some process to complete, so you want your newspaper because I just wanted to spend some time on newspaper. So you take your dog and like, good boy, good boy. Here, get a Post-it, and in the Post-it you say, Mom, give to my dog the newspaper so that it can bring it to me. And so the dog comes, and the mom sees the Post-it and gives to the dog the newspaper. And now, of course, the dog like say, no, cookies, cookies. I want the cookies. Why have a newspaper? Who cares about the newspaper? But the Post-it says newspaper. So there is both things are property of myself. Those are my cookies, not my sister cookies, my cookies, my newspaper. But the delegation I gave to the dog is only for the newspaper. So it doesn't matter that I have access to all of these things. What it matters is what I delegated my dog to do. And it doesn't matter that this delegation says can have a newspaper. It's only my newspaper. It's not my sister's newspaper. So I know it's silly, but you would be surprised by how much light I've seen in the eyes of some of the colleagues that I use that. So now let's go with a formal language. Now, every operation that you have, like every entity you have, typically will have permissions associated to it. I can eat cookies, I can read file, I can send mails. And all of those things require permissions. Like substantially, there is like a Boolean which says, yeah, can do this, can do that. Users typically are granted what we call privileges, like things that they can do. So if I create a file, typically that comes with a number of perks, which is like deleting, modifying, reading, and similar. Now, when I work with one application, I can go to this application and give what we call scopes, which, as the name implies, scope down my privileges. It establishes what are the things that the application can do on my behalf. So, for example, if I have all the capabilities for manipulating my files, but I give files read to an application, that application will only be able to file read, no cookies for the application. Great. Perfect. So remember the thing about consent. On the first time in which you try to get, if an application tries to get a token on your behalf, you'll be prompted with this consent. And when you grant this will be saved for you as the user. The default is that every user grants consent. So if a colleague of mine, a colleague of Mario, tries to get the same token, they'll be prompted again, unless we use one thing which we call admin consent, which is the ability to actually consent to the entire org at the same time in one single flash. That's the high level of it. Still alive? Barely. Okay. Now, let's talk about the next scenario. Now, the name Agave, of course, as I said at the very beginning, Scandinavian joke, don't Google for it. In this case, it happens to be the same as our internal code name, but again, just search for Office add-ins, don't search for Agave. Now, this is a very interesting scenario. Once again, we have the Graph API. Once again, we have a user. Once again, we have Azure AD, and we have a portal that goes with it, which is the same portal as before. But this time, your user is interacting with an Office document. You have this Office document, say, like, imagine it's Excel, for example. Now, the user is already signed in Excel. So Excel substantially has already a refresh token. Now you know what that means. This refresh token is assigned to Excel. Now, we devised a system in which you can deliver your own content within the surface of an Office client using this add-in model. But we had one challenge which gave a headache to my org and the Office org for quite some time, which was, how can Excel, which has its own refresh token already, which is assigned to Excel, allow the add-in to do complete single sign-on. The user shouldn't be prompted again to access the graph APIs as the add-in and not as Excel, so that if you want to give a specific consent to specific add-ins, you retain that ability, like your management can actually manage the level of access that you give to every add-in. So we thought and we thought and we thought about it, and we came out with this solution. Now, imagine that you have your backend. Whoops. Imagine that you have your backend from where you serve the JavaScript of your application. As you guys might or might not know, when I write an SSO plugin, what's happening is that I'm substantially injecting JavaScript in the surface of my Office client. So you serve these from a specific domain, and then you have one web API which sits in there and waits for calls from your own JavaScript. So what happens is that there is a specific flow which Excel or any other client can do to get a token, an access token for your own web APIs. So now you have this token which comes from Excel for your own web APIs. And now your add-in can use this token for performing calls to your web APIs. We have another kind of SDK, which we call the middleware, which is capable of intercepting incoming tokens and validate them, decide whether they are good or not. And then, once you have this token, remember your goal remains to call the graph. You can use, this time, the usual MSAL, the MSAL that we had earlier, for requesting the actual token for the graph, this time as your add-in. So what happens is that you use MSAL for requesting a token using a flow which we call on behalf of. This flow entails sending the token that you received, which proves that you have a user, and using your own key, if I manage. And this time, what you get is our good old graph token, sorry. You get your usual couple of refresh tokens and access token, and now all you needed to do is just to make your usual call to the graph, and this call will be performed exactly as you. Now, this is not the easiest of the flows, I agree, but the good news is that this mostly occurs behind the scenes. That's to say that you just follow the instructions, which, by the way, I didn't call this out. Every instruction here has this link to the actual instructions that you can follow for making happen exactly the things that I'm showing you on the UI, on stage. And substantially, this thing will happen behind the scenes, but you don't really need to worry about it. What happens is that you register your application with the Azure AD portal as a web API, and then you just follow instructions on the term of the kind of permission that you want to grant for getting to the graph, and that's it. Fair? There was the developer that built all this, and he disappeared. Sorry, disappeared. Like probably was butchering his technology so badly that he decided he didn't want to see it. So what I'm going to show you here is exactly the sample that you can get if you follow that address. And this is a super simple add-in which lives inside Excel, and it gets a token for listing the content of your OneDrive. So super simple. And as you can see here, I have one web API, classic web API, which is using this middleware in front of it for dealing with auth. And then I have my this manifest, which substantially tells to Visual Studio how to create the environment for running a test instance of this add-in. So let's do this. Now, this thing is going to call a special debug version of Excel. And here it is. And now I need to switch from my account to Mario. Okay. And now, here it's loading the JavaScript from my IIS Express. And here, as soon as I click get my files from OneDrive, I'll bounce back in here. Here, I had a breakpoint at the beginning of my web API, so I successfully called this web API. And here, what you see below, I won't go into line by line. You can see it on your time, but substantially what I do is I extract the access token that I receive in the first call. I create a confidential client application, which is different from the one I created earlier, because this one runs on a server and it has a key. So it's a different class. It's the confidential class. And then I just use this token, getting this, use the acquired token on behalf of, which is the flow that I described on the slide, for getting a new token for the graph. And once I just say continue here, as you can see, I have a large collection of images, one. But it's enough for showing you that it works. So this is a very, very powerful way you can use for putting your experience right where the user is operating. Like, you can embed that capability there. And in the past, we had to really do all the contortions for giving you the chance of doing single sign-on. And in fact, very often, I don't know if you guys ever had this experience, but you used the add-ins, and the user had to sign in again, despite the fact that they were already signed in the Office portal, in the Office client. And instead now, it works very smoothly. One thing I'd call out in this slide is that the communication between your add-in and the Office host is done using special JavaScript APIs, which are made available by every Office host. Like when you use the add-in model and you create your JavaScript for running inside Office, you'll just automatically find specific JavaScript APIs that you can use for asking the Office host to get that first token that allowed you to start all this chain. All right. You more or less still seem alert. Who's doing email? No one. That's fantastic. Well, instead of doing emails, we just left, which is a very good idea. Okay, just for giving you a super quick introduction on what I've done on the web API side, we use this thing called ASP.NET middleware. So in parlance of what I did earlier, this is this component. This component, the one that was in front of my web API and intercepted the various calls so that I could extract the token, validate the token, and then pass it to the next layer. And have you ever built a web API on ASP.NET? 1, 2, 3, 4, 5, 6, not many. Okay, what about a web API on any other platform? All right, Node? How did I guess? Great. So substantially, the idea is that you place this code in a web server of some sort, and then you listen to requests. And once those requests come in, you process them. In the past, ASP.NET was strongly tied to IIS. So you wrote modules that process requests in front of your app, such as the modules for doing authentication, as IIS extensibility points, like IIS modules. In the new world, this thing doesn't work all that well because we now want it to work across platforms, also on Linux and on Mac, where IIS Express doesn't exist. So there is now this concept of middleware, which is a nimble, small HTTP processor, which is designed to be independent from the server, and that comes in different flavors, depending on the protocol that you want to support. You have different modules. We used Auth2 right now for the web API, but for doing OpenID Connect, for example, a website, you'd use OpenID Connect. And it's super handy. Like you write, like if you'll come to an AD session tomorrow, you'll see the code for this. You write just a few lines of code comparable to what we did on the client, and you just basically say, I want tokens from that guy, and everything else happens automatically. So pretty handy. And then my friends from Experience.net wanted me to add these slides, so I added them, and I've shown them to you. So check. No one can tell me I didn't do it. Great. And so now we can choose between doing the single-page applications or doing calling from a code behind from a website. So let's take a vote. How many of you wanted to see the single-page application flow? Can you extend your arm to your full length? Thank you. What about the code behind of the web app? It's a very close one. I could talk really fast and do both, but it wouldn't work. Let's do a single page app, because of a web app we have done so many times, and I rarely had the time to actually do some single page app in details. So here is how it works for a single app. You have the usual graph that you want to invoke. You have a usual user, but this user is using a browser, a very large browser, because I need room for putting stuff in it. We have a usual Azure ID, and you always put your application through the ARP. All right. A single-page application, as you guys already know, is substantially content which gets served from a server, like in the canonical case, one single HTML page, which comes with a JavaScript logic, which after the initial postback will update the UI in regions. You just like do web API calls to your backend, get back content, and use JavaScript and the DOM to update things locally. It's super powerful. It's very responsive. It's on like Outlook Web Assets and Gmail and other popular applications. Now, how do you do these how do you implement one of those using one of our SDKs, and how do you call the Graph API? Now, this is going to be fun. Now, say that you get your content back, and say that you, together with it, you instantiate our MSAL JS library, the JavaScript version of MSAL, which is designed to work with single-page applications. Typically, what happens is that your app, at first, at sign-in time, gets redirected to AD. The browser does the authentication or the pop-up, depending on how you want to drive this thing, and you get two things out of this. You get a cookie, which represents the fact that you successfully authenticated to Azure AD, which we'll keep here. And then you get a new kind of token, a token we didn't discuss earlier, which is an ID token. An ID token is a token designed to represent the identity of a user. There are no scopes in this token. This just says the user successfully authenticated, and here is the app for which it happened, and here are some parameters of a user. And this token gets cached by MSAL JS. And then this token is supposed to be sent to your own backend, where, with the same middleware that you used earlier, you validate it. And if you like it, you are in business. The user is signed in. Why do you do this step? You do this step because the ID token that you get is the only artifact which has you as the audience. So if you would skip this step, for example, like the Office guys usually ask me to do, what happens is that anyone could potentially obtain a token for the graph, for example, and somehow inject it in your application and use it. And this might lull you into the illusion that the user successfully signed in, but you cannot say that, because the fact that I have a valid token for the graph doesn't mean that it was a valid token for the graph for my application. So typically, there is this first step that you use for signing in. Although, technically, if you want to skip it, you can also skip it. I don't recommend it for this reason, but if, for example, you want to skip it and you want to go straight and call the APIs, technically you can do this. But say that you have done this model, and say that now from your JavaScript you wanted to call the graph APIs. How do you do that? Well, MSAL JS gives you an acquire token silent method, which at this point you know how it works. You just get back the token that you want without popping any experience. But how does it work here without any refresh token? There is no refresh token in there. Well, the trick here is what I described earlier, I have a cookie which represents the session I have with Azure AD. So now I can open a hidden iframe, and I can use that cookie for making a request to Azure AD saying, please don't show any UI. Please give me a token for the graph with the scopes that I specify. And also, please return these in a fragment so that these tokens can actually be returned to the browser itself. Like the property of the URL fragments is that it is only delivered to the browser, but not to the server side. And substantially, that's exactly what happens. You use this little dance, you get back your access token, and now this access token gets cached, and now I can use it for calling the graph, just like I did before. And that's pretty much it. The moment in which the access token is about to expire, you can use exactly the same trick for getting a new copy of a new token. Or if you needed to call any other resource, which is not covered by this, you can do exactly the same. Now, let me just show you this in action. Yep. Again, this one is a sample that you find in the address that I provided. Like once you'll get the deck, I didn't give it to them yet because I didn't want to show this in advance. But as soon as I'll give the deck and they'll make it available, you'll see that on top of every instruction there is a URL. You go to that URL and you find exactly the same stuff. So as you can see here, this structure is a classic ASP.NET app. The only difference is that I also have my JS in there, and I initialize my JS with my client ID and the tenant that I want to use, and that's it. Super straightforward. So just for showing you that it works, I hope. Every time I use Chrome, there is this small thing which comes up, and my heart sinks every time. I think there's something wrong. Instead, they are just being verbose. So just for showing you the experience, see, login pops this thing out. So I can be Mario. Sure. Really? Oof. Great. And so here, like by identity demos, usually, if they work, they are boring. So that's kind of what happened in this case. So as you can see here, I just used pure JavaScript, like pure jQuery. I didn't use any of the other stacks like Angular or React and similar because we don't have them yet, but we are thinking about it. In fact, let me ask you, how many of you would like to have a projection of these in Angular 2? Can you keep the arm up so that we can count you? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, 25. What about React.js? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's harder to count in English. All right, 20, so slightly less. Great, thank you. So we are getting all the possible sources for deciding which one to do first or which one to do if we do only one. Okay, so as promised, I'm skipping the web app. And, yep, later on. So, as I said at the very beginning, authentication is hard, but after this, I hope that you'll agree with me that it's hard-ish. That's to say that if you are following canonical scenarios, again, think mobile app, 2 lines of code, just one short getting a GUID from a portal, and I'm in business. So very, very quick. And as long as you stick with instructions and SDK, hopefully you'll be fine. If you have questions, I'll be here. Thank you for staying all this time.